Hello everyone, welcome to Optics Anand Academy. Today I am going to discuss a motion in a plane. Today's topic, let's see the motion in a plane. Motion in a plane. So this is the fourth chapter in first year physics, okay na? Which is very important for 4 marks plus 2 marks problem. Okay, for IPE weightage only 4 marks question will be covered and 2 marks problem will be covered, and for EAMCET, JEE and NEET, okay, for these examinations, so we will they will cover so lot of questions from this motion in a plane, that is obliques projectile, addition of vectors, that is addition of triangle law of additions and parallelogram law of additions. So from this many questions will be appeared, okay, that is polygon law of additions. So some different topics or concept will be covered from this motion in a plane for the EAMCET, IIT, JEE and NEET. For IPE intermediate public examination only 4 marks question and 2 marks problem will be covered. Now let's see the introduction to the introduction. So here let's see the classification of quantities. Generally, what is mean by quantity? Quantity, we all know that the vector quantity nothing but, for example, force is a quantity, physical quantity. Okay, velocity is a physical quantity. Okay, na? Distance is a physical quantity. So these all are the physical quantities. What is mean by physical quantity? Physical quantity nothing but a quantities which are used in the physics laws. Okay, a quantity, these are the quantities which are used in the physics laws. They are called the physical quantities, and these physical quantities are of 3 types. These physical quantities are of 3 types. Physical quantity, physical quantities are of 3 types. First one is vectors. First one is vectors, and second one is scalars. Second one is scalars, and third one is tensors. Tensors. Now listen to me. So already we discussed what is physical quantity. Physical quantity nothing but a quantities which are used in the physics laws are known as physical quantities. They are of 3 types or 3 classifications, that is vectors, scalars and tensors. So here let's see the definition for the vector and what is mean by vectors. Vectors nothing but it is a physical quantity. It is a physical quantity which is having both magnitude and direction. Okay, for example, so and this is some 10 meter or 10 centimeter, you can say 10 centimeter. Okay, so this is about 10 is the magnitude, centimeter is the measurement or unit. 10 is the magnitude. Okay, from here to here is 10, that is magnitude. And if it is having some direction, this is known as so magnitude. It has magnitude and direction. Magnitude and direction. A quantities which are having a magnitude and direction and also obeys law of addition of parallelogram law or law of vector additions, otherwise called law of vector additions, and also it obeys commutative property. And So if all the physical quantities only having magnitude and direction, it is never be called as vectors. It must be obeys law of addition of parallelogram law or law of vector addition, and it must be obeys commutative property or commutative law. Okay, if a physical quantity obeys these two laws and having both magnitude and direction, then we can simply call it as a vector. Now let's see the example for the vectors. What is the example for the vectors? So for example, velocity, displacement, acceleration, etc. So if you take velocity, it has some magnitude and also having direction, and it obeys addition of parallelogram law, and it obeys commutative property or commutative law. If you take displacement, we know that it has having magnitude and direction and obeys these two laws, and if you take acceleration, it has magnitude and direction, obeys two laws. Okay now, and for example, we all know that current, that is I, which measures in amperes. Current also having a particular magnitude and direction, because the flow of current having some particular direction, it flows in a single way, even though we never call it as the current which is measured in amperes as a vector quantity, because it does not obey the law of addition of parallelogram law and does not obey the commutative property. Even a physical quantity having both magnitude and direction and does not obey these two laws, that physical quantity never be called as vector, vectors. This is a very, very important notice for, notice. That physical quantity must have these two properties and obey these two properties, then we can simply call it as vectors. So let's see the representation of vector ladder. Now what is mean by scalars? Let's see. Scalar nothing but it is a physical quantity which has only magnitude but not direction. Direction is absent, only magnitude is present. Okay na? And example for the scalars. Are nothing but distance and mass, length, area, etc. Okay, if you take any physical quantity like distance, mass, length, area, etc., you take anything only having magnitude but not direction. Distance, it does not having direction. Okay, distance nothing but the total path length is known as a distance, whereas displacement nothing but what? The distance between two successive points, or distance between the 2 points, or the shortest distance is known as a displacement, whereas distance is nothing but total path length which is travelled by the body is known as a distance. Mass, we know that 10 kg, 20 kg, 5 kg, 10, 5, 20, that is a magnitude, whereas kg nothing but units or measurement. So length, that may be 5 meters, 10 meters, 15 meters, here 5, 10, 15 are nothing but a magnitude. Okay na? This length never not having direction, mass also not having direction, and distance, area also not having direction, only having magnitude. Now let's see the tensors. What is mean by tensors? This is very, very important. So everybody will know that the classification of physical quantities are only vectors and scalars. Nobody will know tensors. Yes or no? Tensors. Let's see. Tensors nothing but a physical quantity. It is also a physical quantity which are having magnitude and direction, but in different directions and different magnitude. different direction and different magnitudes. Okay, now here for scalars only magnitude but not having direction, magnitude and having particular direction or specified direction. Here the tensors also having magnitude and direction in a different way, For example, moment of inertia, we all know that moment of inertia. Yes, you will study that moment of inertia in 7th chapter of first year, that is system of particles and rotatory motion. In that we will discuss the moment of inertia, that is I is equal to mr square. Okay, this is having magnitude and direction but in different way, in different magnitude and different direction. So stress, okay, here stress nothing but what? Stress nothing but we know that force by area, force acting per unit area, this is known as the stress, and this stress having magnitude and direction in a different way, in a different direction. So this is about the tensors. Okay, now already we have discussed the classification of physical quantities, that is vectors and scalars and tensors. Now let's see the how to represent the vectors. Let's see. Now let's see a representation of vectors. Representation of vectors. We all know that vectors having both magnitude and direction and obeys law of addition of parallelogram law and commutative law, right? So for example, so this is known as a line segment. Yes, so this is a line. First let us see line. What is mean by line? Okay, so it is having a, let us see magnitude and direction here. So I will explain simply. Let us check magnitude and direction for the line. So line which has two sides and one side can be extended, other side can be extended. So if you check the magnitude for this, we cannot measure this line length because this is the point which can be extended and this is the point which can be extended. It does not having a fixed 2 points. So magnitude is 0 and it is not having a particular direction. So direction is absent. Okay, now let's see the line segment. Line segment nothing but what? A line which is having with two fixed points. So this is a fixed point and this is a fixed point. A line which is there in between the two fixed points is known as the line segment. For example, magnitude. So if we check the magnitude for the line segment, yes, we can measure the magnitude. For example, that is 5 meter. Yes, exactly, because this is the end point and this is the end point. In between there is a length. So simply we can measure the magnitude. For direction, it does not. Okay, na? We cannot measure the direction for the line segment. Okay, now let's see a ray. Ray nothing but what? This is a ray. So ray having a particular direction does not having initial point. It does not having initial point, so that if we want to measure the length of the ray, we cannot measure. Okay, we cannot measure. Magnitude is absent, but having some particular direction. Yes, a ray having a direction but magnitude is absent. Magnitude is absent. Next, let's see. I am taking a line segment and I am taking a ray property. A line segment having particular direction is known as a vector. Vector nothing but having vector nothing but what? Vector nothing but a directed line segment. This is directed line segment. The directed line segment. Let us check the magnitude and direction here. So magnitude, yes, it is a line segment having magnitude, and it is having a direction or ray property, that is having direction. We can simply measure both magnitude and direction. So we can simply represent or define vector nothing but a directed line segment. A directed line segment. Otherwise we can call it as a physical quantity which has both magnitude and direction. Both magnitude and direction, and which obeys law of vector additions and law of commutative property. Okay, so this is known as vectors. Now let's see how to represent the vectors. This is the basic definition of the vectors. Now let's see the representation of vectors. How to represent the vector? For example, this is, yes, it is having initial point, or we can represent like this. Yes, this is line segment and direction, and line segment initial point is there, must be, it has initial point and direction. So I am taking this arrow here, whatever the arrow is there in middle, I am taking at end. There is no problem, wherever we can take. So let us consider this is A, B. Initial point is A and end point is B. So this is the representation of vectors. This initial point known as tail of the vector, tail, and this is head of the vector, head. Okay, this is A and B. So AB is a vector, AB is a vector, and that can be simply written as AB bar, or we can simply write it as AB arrow, like this. And this arrow represents the direction. Here AB represents, from A to B represents magnitude, and this arrow or this bar represent direction. So if you write only AB, this is represents the magnitude of vector, magnitude of vector. If you write like this, it represents vector. So from this we can, so let us say A bar, small a bar is a vector. Okay, instead of writing AB bar, just I am writing A bar, so that we can simply say AB bar equal to A bar. So A bar is a vector, AB bar is a vector, nothing but A bar is a vector. So this is the representation of vectors, representation of vectors. So now let's see what are the classification of vectors, types of vector. Let's see the types of vectors.